Finding x and y intercepts of a rational function, if they exist, is the same as doing that process for any other function. For finding x-intercepts, we generally set the function equal to 0 and solve it. And for finding y-intercepts, we plug 0 in for x and solve for y. It's possible for rational expressions or rational functions not to have any intercepts because we might have asymptotes on both the x-axis and the y-axis and the graph won't cross there. But that just is sometimes that happens. Okay, so the fact is I've got here to find x-intercepts, we just set the numerator equal to 0 and solve. Why not the entire fraction? Well, let's talk about that really fast. If we take the entire fraction, x plus 1 over x squared minus 9, and we set that equal to 0 like we normally would to find an x-intercept, we would then cross multiply this times this, and what happens when we multiply by 0? Poof, it turns into 0. So therefore, all we need to do is set the numerator equal to 0 because the denominator is going to go away anyway. Alright, this gives us x equals -1, so we have an x-intercept at -1, 0. For our y-intercept, we're going to plug 0 in for x. So 0 squared plus 1, 0 plus 1, and then 0 squared minus 9. So that gives us 1 over -9. So our y-intercept will be at 0, -1/9. So obviously this has both one x-intercept and one y-intercept. Okay, question 2. Again, we're going to take our numerator. Now, in both of these examples, our numerator is linear, which means we're just getting one x-intercept for each one. If our numerator was a quadratic, then we would possibly get two x-intercepts for the quadratic. Or if it was a cubic, we would get 3 x-intercepts if they were real numbers. I just wanted to make sure that that was clear, that it might be more than one x-intercept or something like that, although it'll never be more than one y-intercept, or it wouldn't be a function. Okay, same stuff we learned in chapter 1. So I can't talk and write the right stuff at the same time. Our x-intercept on this one would be -3, 0. Our y-intercept would come from plugging in 0. So we have 0 plus 3 over 0 squared plus 9, which gives us 3/9, which reduces to 1/3. So our y-intercept is 0, 1/3. At this point, you're starting to wonder if y-intercepts are always fractions. No, but frequently they can be. Okay, next. We're going to take -2, which is our numerator, and set it equal to 0. Well, that's impossible. So that means there is no x-intercept. Then we're going to take the entire question and throw a 0 in place of x. So we'll have a -2 over 0 squared minus 9, which gives us -2 over -9, which gives us 2/9. So there is a y-intercept at 0, 2/9.